Good morning, children. Today our topic is fun with magnets. So what is a magnet? You all might be playing with a magnet. It attracts the metal things, especially iron. We use magnets, right? So magnets are used to attract the pins, attract the nails, attract the nuts and bolts. Okay. So where do you get these magnets? Just if you look around in your house, at which places you find the magnet. So magnets are used in different items for the purpose of sticking them to the metal objects. If you see your almirah or refrigerator, you will be finding the stickers that are stuck to the fridge door or almirah door by a little magnet. You can take it out, again you can place it back. If you observe the sticker on its back side, there you will find a little magnet. If you go to a office or a bank, there you will see the clerk will be having a pin holder. In the pin holder, there will be so many pins which are attached to the pole of the pin holder. Even though he takes the pin holder and keeps it upside down, no pin falls down. They are sticking to the magnet part of the pin holder. So by that, the pins are not easily falling off. So by that, the person can easily pick one pin at a time. So that is the application of the magnet. And you see that if you go to any river bank, you can find that there in the river people usually throw coins. It's an auspicious thing, they believe, in throwing coins. So some of the boys you can find that there they will tie a magnet to a thread, they will put it in the bank of the river. So it will attract the coins, they pull out and they take the coins. Because coins, certain coins are made out of steel, steel is also having the property of attracting to magnet. So likewise, we find so many applications, right? Even you see in your pencil box, some of the pencil boxes will be having a magnetic attachment. Even for your mother's wallet or the handbag, whatever the zipper and the cover will be having a magnetic button, so by that it will stick and it keeps tightly. So likewise, in many of the places the magnets are used. Okay. So large sized magnets are used by magnetic crane, which is used to remove the metallic junk from the scrap. See here, there is a pile of scrap. So all over this is junk. So among this junk, among this heap of junk, there will be so many metal items as a scrap. To separate them, they use a huge crane. Which is fixed to a magnet, a very big magnet. So this magnet, if it is kept or released over this heap, it will attract all the junk and metal scrap, the parts of the vehicles, iron items, metal items, cans, tins, all these are attracted by this magnet. So this is one of the application of a magnet. Okay. So likewise, we found plenty of applications of magnets in our day-to-day life. But how these magnets are made? From where do we get these magnets? So now let us see how magnets were discovered, right? How magnets were discovered. That means the statement it shows that they were discovered, they were found. That means they were already there existing. So magnets basically two types, natural, artificial, that means man-made. So naturally some magnets were there that were found by some person. So what was that story? So that was Magnus, a shepherd in Greece, a Greek shepherd. He was taking care of his sheep, taking the sheep for grazing on the mountain side. It was a rocky mountain. So he was climbing the rocky mountain and he was controlling the ship with the help of a long stick. So he used to carry a stick all the time with him to control the ship, and the stick also helps him to climb the mountains while getting down the mountains, that is for a support. So for his stick, at the end of his stick, if this is the stick, at the end he has got a metal wrapping, an iron wrapping, iron cap. So end of his stick has got an iron cap. So when he was taking his ship towards that mountain, on one day, suddenly his stick has got stuck to a rock. It got fixed to the rock and he felt it's so hard to pull the stick. Right. So there is no gum. There is no gumming material, just the stick was pulled by the rock and stuck to the rock. He felt so hard to separate them. So by that incident, that fellow Magnus, he found a natural rock which acts like a magnet. So such kind of rocks, the rocks that have the property of attracting iron items, metal items, were called as magnetite that time, magnetite. So actually this name magnetite has come from the person Magnus. Some people believe that it was happened in a place called Magnesia. So that's why this magna has come, but the fact is unknown whether that is the name of the person or the place. But somehow the rock has got the name magnetite, which generally contains iron. It was a natural magnet. No one made that, just it was existing in the nature. It was made by the nature. Because of some atmospheric conditions, the rocks may undergo certain changes. So likewise, those rocks were undergone certain kind of changes, and that was the natural magnet found over there, magnetite, iron, contains some iron. So this magnetite, it was considered as the natural magnet. Later people used it to collect such kind of stones that have the magnetic property and used as a magnets. Later on, in the modern era, people started making their own magnets with the help of iron. So iron is used to make artificial magnet. The magnets are made in different shapes. Artificial magnets are available in different shapes. Disc shape, bar magnet, circular magnet, horseshoe shape magnet, like this. Likewise, we find different shaped magnets, bar magnets, disc magnet, horseshoe shape, circular, likewise. So the magnets, they have got so many applications already we have. So already we have seen the applications of magnets. Here we are just looking at the types of magnets and how they were discovered. There are two types of magnets, natural and artificial. Artificial magnets can be any of the shape. Cylindrical magnets are also available, and dumbbell shaped magnets are also available. Likewise, so many magnets are there. So you can play with magnets, you can have fun with magnets, so that you can understand the property of magnet very well. Here there is one activity suggested in your textbook to do with. For this activity you need a simple stand over here, and take a clamp, take a paper cup, put some magnet in this and cover with paper. So no one is able to see where is the magnet. Now here the task is, at the base of the stand, take a thread, fix a thread here, and at the end of the thread you keep a pin. You keep a pin. Now you see that the pin is standing against the gravity. Actually, if this is the thread and this is the pin should fall down. But the pin is standing straight without any support. That means it is being pulled by the magnet which is kept inside the cup. Due to the influence, magnetic pull of the cup, the pin is standing. So this is an activity. So you can amaze your friends by doing this. But you should take care that you should have a proper magnet. You should maintain proper distance between the pin and the cup. If the distance is too high, the pin may not stand. Right. So take proper care and do this activity and have fun. So now let us see magnetic and non-magnetic materials. So what are these? We have a magnet with us. Just you brought one magnet from the store, from the stationery shop, you brought one magnet. You have so many materials in your pencil box or in your bag: pen, pencil, eraser, sharpener, compass, protractor. So likewise you have so many materials in your bag, and study room, in your classroom you have so many materials. So that you wanted to test whether the materials are magnetic or non-magnetic. Just you are testing. How you can test? You can take the magnet into your hand, you can touch with the object and see that whether it is attracting or not. If the object is attracted, it is a magnetic object. If it is not attracted, it is a non-magnetic object. So just you can draw a table. You can make two columns. Here you write name of the object. You can write magnetic or non-magnetic. You take n number of items, that is your choice and your time. You can take scale, non-magnetic, pencil, non-magnetic, eraser, non-magnetic, compass, magnetic. So likewise you can take n number of items and you can check which is magnetic and non-magnetic. The material that attracts to a magnet is magnetic material. The material that do not attaches or attracted by a magnet, it is a non-magnetic material. So we can use this bar magnet to do one more activity, that we can find out how much percentage of iron fillings or magnetic materials are there in the soil of a particular place. In your colony, you can go around, you can take this bar magnet, you can put it in the soil and rub it. Then you will find your magnet will be stuck to a lot of dust and sand particles. Just you can take it out and blow it gently. So all the dust will go away, the sand particles will go away, but it will be having some parts sticking to that. So these are iron filings. So what are these iron filings? Small bits of iron broken and it is mixed with the soil, right? You know that iron is a corrosive metal. When iron is left outside, it breaks by corrosion, rusting. So the small pieces of iron fall all over. The percentage of iron filings is different from place to place. In some places you may find a lot, in some places you may not find anything also. So this also you can make a table on which you can write, you have gone to your colony, write the name of your colony. So how much iron filings you collected, yes or no. You have gone to your friend's colony, your friend's place, there you tested, so you write it there whether you got iron filings or not. So in this way we can see, we can test the soil whether they have got the magnetic dust iron filings or not. Right, now see the poles of a magnet. Magnets, they have poles. What are these poles? Say if you have taken a chart, on that just you sprinkle some iron fillings. On the chart you have sprinkled some iron fillings. So there you kept one bar magnet. You kept one bar magnet. So just if you move the bar magnet here, what happens is you can find the iron fillings, they stick to the magnet in one particular fashion like this. You find that the iron fillings are stuck towards the ends of the magnet when compared to other parts. Here you find more iron fillings are sticking at the ends. So the poles of the magnet are towards the ends of this magnet. So poles are found at the ends of the magnet. Different magnets have different shapes. Even then you can take the different shaped magnet and you can try with this, at which end more iron fillings are getting attached. Those ends are the poles of the magnet. So the magnets, they have poles. These poles, they help us to find the directions. How a magnet and its poles help us to find the directions. You know one fact, you must remember one fact, the earth itself, it's just like a magnet. The earth itself, the whole earth itself, it's like a magnet. It has got magnetic poles, north pole and south pole, right? So, if you have a magnet with you and if you suspend the magnet freely in the air, it will show one particular direction. That means the poles of this magnet, they will get aligned with the poles of the earth. So, this helps us to find the directions. In the ancient China, there was an emperor called Huang Ti. So, this emperor has got a special chariot. He used it to travel to different places. To find the direction, he has got one setup to his chariot. That is, there was a lady figure on that particular chariot statue. So, that one, it used to show the direction. The lady used to rotate freely, but the hand of the lady would be always pointing the south. It is arranged in such a way. That means some kind of magnet is fixed to the model of that lady, the statue of that lady. So, by that it is pointing towards the south. So, by that he can easily find out the direction, right? So, what does it indicate? A freely hanging magnet can show you the directions. Let us do a simple experiment. So, here we have a setup, we have a stand, and the stand is having a clamp which is having a freely hanging thread to which a bar magnet is fixed. This is a bar magnet. So, now you just put a mark on the bar magnet to one of the ends, not to the two ends, one of the end, and now rotate the bar magnet and wait for some time. Slowly the bar magnet, it comes to one position and rests finally. You see that in which position it is resting. So, this is final, it is not moving anymore, it has fixed to one position. Then you take a paper at the bottom and on the paper just you mark the direction of the bar magnet, how it is fixed there. Again you rotate the bar magnet, it gets rotated and oscillated for some times, it swings and finally it settles and comes to rest at one position. Now you can observe that the bar magnet, it comes to the similar position to the previous position, exactly just as like the previous case. You can compare it with the paper and the mark. How many number of times you do this with a bar magnet, the same will be repeated. The same happens again because the bar magnet has got the poles which are aligned with the poles of the earth. So, the bar magnet has got two poles, north and south. The north pole of the magnet, it's seeking towards the north pole of the earth. South pole of the magnet seeking towards the south pole of the earth. So, in this way, the magnet, it shows the poles. If you do this experiment with something else, if you keep a pencil or a wooden block and you rotate it, so what happens? It gets rotated and gets settled down in one particular direction, but not the same direction always, because it is not a magnetic material. But if you do that with a bar magnet, all the time you will find that the bar magnet comes to rest in only the single position, right? Only to the same position. So, this helps to find the location. A freely hanging magnet helps in finding the directions. So, these kind of magnets were used by the ancient people to find the directions. They used it to travel a lot by their walk or by their animals or vehicles. There were no road signs. Now, if you take your car or by bus, you go to the roads, national highways, you can see that very clear signboards indicating how much distance you travel, how much distance that you have to travel to reach your destination, what directions you can take. It's more advanced. Now you have your GPS navigator. The GPS navigator is telling you what is the position of your car, how much distance you have to travel, after how many meters you have to take left, right. So, such a way you are guided, you are navigated. But that much facility was not there in the earlier times. They used to carry their own natural magnets. By hanging them, they use it to find the direction. How a magnet helps to find the direction? Magnet generally points towards the north and south pole. If you just have the look of sunrise or the position of the sun, it helps you to find out the location, because we know the fact sun rises towards the east. But of course, always the position of the sun is not fixed there, but it can help us in one way. What is left to the sun is north, right to the sun is south. By this indication, by using a freely hanging magnet, you can easily identify the directions. Later on, the people, they developed a device to find the location or directions, that is the magnetic compass. So the magnetic compass is a device which is having some kind of labeling inside showing the different directions, and there will be a double pointed needle. The needle will be having 2 points colored differently, one with blue and one with red, the north with blue. So it will be showing the directions exactly. Using this magnetic compass, the navigators, they use it to find the directions and travel. This is how the magnets, they helped us a lot in finding the directions. So we know the magnets are two different types, artificial and natural. Natural magnets are very difficult to find, and they are not as magnetic as, because they have impurities. So artificially we can make magnet. How we can make a magnet? What is the raw material that you need to make a magnet? We can make an iron piece into a magnet. If you have an iron piece, if you have a rectangular iron piece with you, you have a rectangular iron strip or iron bar you have. So now you are going to make this iron piece or iron bar as a magnet. To do this, you need to have a magnet. So you have a magnet, a bar magnet. So this is your iron piece. You have taken your bar magnet and you are keeping your bar magnet on this surface, and you are dragging it here in this way. You are dragging it all the way. You are not lifting, just you are touching the magnet to the iron piece and you are dragging. And again you are lifting the magnet up. Once you reach the end, you are lifting it. Again you are touching the magnet here to the iron strip and you are dragging. Just you are dragging. You are touching to the magnetic strip and dragging. Once you reach the end, you are lifting the magnet again. If you do this for 30 to 40 times, if you do this for 30 to 40 times, this iron strip becomes a magnet. But here you have to do the procedure correctly. That means you have to take a bar magnet, touch the bar magnet, one pole of the bar magnet, not the complete bar magnet, only one pole. You have to touch it to the strip here, drag it all its length, lift it again and do that again. Repeat it for 30 to 40 times. And do not change the pole in between. First time north pole, second time south pole. If you do so, it doesn't work. Which pole you are selecting, the same pole and the same direction 30 to 40 times. If you repeat the process, you can find this iron strip is turned to a magnet. You can test it, put some pins, metal pins, they will be attracted to this. So it is confirmed that you made the iron bar into a magnet. You can make a pin or a safety pin or a clip into a magnet with the same experiment. Now you can take the pin and fix it to a cork. So this is the pin which you have magnetized and you kept this pin to the cork, and you can keep the cork in a mug of water. This is the water. So what happens here? The cork, it floats in the water. So by the needle, it freely rotates and it will show you the north and south directions. You can use that cork as a magnetic compass. It will show the directions. Right. So by this method, you can turn a pin, a nail, any iron object, a screwdriver into a magnet. That means, that is by rubbing with a magnet from one end to another end in the same direction for a number of times, you can make an iron piece into a magnet. How? That is by rubbing. Rubbing with a magnet, we can make an iron piece into a magnet. This is how we can make your own magnet. So attraction and repulsion between the magnets. So far we discussed that the magnets get attracted to the magnetic material, or two magnets they get attracted to them. But here we are going to learn a new concept that the poles of the magnet, they play a major role in deciding whether the magnet is going to attract or get repulsed. Repulsions are also seen in magnets. Let's see how. This is a bar magnet with its north pole here, south pole here. This is one more bar magnet. This is south pole here, north pole here. Right. We have taken one more setup, two more bar magnets with the north pole, south pole, north pole, south pole. Here let's see, if I bring these two bar magnets close, they will repulse, because opposite poles always attract, like poles always repulse. These two are the like poles, south and south, they will repulse. If you bring both the magnets closely, they will go away from each other, because here also here the south end, here are the south end, both are like poles. So like poles, they will repulse. Whereas in this case, here we have the south pole and north pole. When you bring two magnets with dislike poles, they will get attracted. Dislike poles, this is north and this is south. So when you bring them close, they will get attracted. Right. So magnets, they have attraction as well as repulsion depending upon the poles. You can play with this. You can take one toy car. You can take a toy car like this, and you can fix a magnet on its top with north pole, south pole. In the same way, you can take one more toy car. So on the top of it, you can take like this, south, south. If you bring this car, this is car A, car B. If you bring this car A close to B, the B will go away automatically. So if you are moving this car A behind car B without any power, without any push, the car B will be moving in this direction. How? Because of the magnetic push. Because the south pole of this magnet, it is pushing the south pole of this magnet. So by that, along with the magnet, the car is pushed. If you just change the position of the magnet, if you bring the north here, north pole here and south pole here, what happens? If you bring this car close to that, the car will come back and you get attached to this. As you are taking this car A back, car B also come back because it is attracted by the south pole. So here one fact that we have to remember, that is, like poles will repulse. Repulsions are seen, repulse. Like poles, repulse. Dislike poles attract. So that is the most important property of a magnet, which you have to remember, which is helpful in your higher classes. That is that like poles repulse and dislike poles of a magnet get attracted. So we have seen the benefits of magnets, the advantages of magnets. They are used at various places. There are so many applications of magnets, but still we can find certain caution with a magnet. So what is that caution? Magnets, they should be kept away from certain items like cassettes. So anyway, nowadays we are not using the magnetic tapes to record the audio and video. In earlier days, in olden days, they used to have magnetic tape recorders and players. So like this, they used to have a cassette for a tape recorder. So magnetic tape on which the audio is recorded. The video is also recorded on a magnetic tape cassette. So VHS system, and in the VHS system you used to have a cassette like this. So nowadays we are using CDs. Anyway, the CDs are also sometimes damaged by the magnets. So the magnets ought to be kept away from the CD-ROMs or DVDs or hard disks. So, this magnetic field may interfere with the data that is stored in the objects like your pen drives or memory chips or whatsoever, CDs and DVDs. And sometimes if big magnets are brought close to the televisions which are used at the tubes, so such kind of televisions, the picture used to be get disturbed, right? So it may damage the certain electronic items. So that is the caution with the magnet.